sun has a gravitational pull that makes the Earth revolve around the sun. Now, if this is a black hole and this is like a star or the sun, the black hole has a gravitational force just like the sun does. It doesn't pull in the sun and the stars, it just sucks it up like a vacuum cleaner. The black hole gravitational force causes the sun and the stars to rotate around the black hole.
Oh, phew, thank God! I can finally get some sleep without having to worry about being sucked into a black hole. Now, hold a sec. Where did black holes get their name?
Well, if you were to travel inside a black hole, there's like this imaginary line called the event horizon. When you go past this event horizon, even light can't escape. And so if light can't escape, that means you can't see the black hole. And if you can't see the black hole, in space, it's just this pit of darkness.
If we can't see it, then how do we know black holes even exist?
Well, there are three things how we know black holes exist. But first, let's go over what describes a black hole. What is a black hole? Well, a black hole is something we can't see, and it's extremely heavy. Black holes have a tremendous gravitational force that allows it to do these three things. Now, the first one we discussed earlier, a black hole, we see suns rotating rapidly around something that we can't see. But we know that that something has to be extremely heavy to be able to have the gravitational pull to make these suns or stars to rotate around it. Well, that's just the first thing. The second thing is, when something gets pulled, a black hole pulls things in to it when it gets too close. So when gases get pulled into a black hole, the black hole compresses these gases. And when it compresses it, the gases become so hot that it shoots up to like millions degrees Celsius. And when it gets so hot, it emits these X-ray lights that we can see coming out near this something that we can't see, the black hole. That's the second thing. Now the third thing is, when matter gets too close to a black hole and the black hole compresses this matter, it's as if you squeeze a grape and the insides just shoot out from the skin. So we see these beams of matter shooting out from near the black hole almost to the speed of light. And it's these three things how we know that black holes exist.
Okay, wait. So, what would happen if a human being were to fall into a black hole? Is that even possible?
Well, if a person were to fall into a black hole, they'll basically be stretched out like spaghetti, like violently pulled apart until there's like nothing left of that person. But luckily, it's impossible for a person to fall in or get pulled into a black hole. Because even if we were able to travel at the speed of light, it would take us thousands of years until we actually reach the closest black hole to Earth.
Okay, so then how did black holes form anyway? I mean, whose idea was it to place such a dangerous object in our galaxy?
The key thing is gravity. Because when a star starts to run out of fuel, gravity causes that star to cave in amongst itself. So it collapses, influences like smaller and smaller components, and this becomes the singularity, the core of the black hole, and it becomes so dense that it has this tremendous gravitational force that is a black hole.
Okay, so you were talking about how the sun collapses when they run out of fuel.
Yes.
But then, how come stars don't collapse when they have fuel?
Well, the star's core is like extremely hot, 15 million degrees Celsius, and it gives off this outwards pressure that counters gravity, pushing in on the star. Like when you boil a tea kettle, like when the tea's ready, and it like the pressure comes out, and you get that whistling sound. It's like the same thing almost.
Oh, so what would happen if the sun were to run out of fuel?
Well, it would probably take a billion years, 10 billion years maybe, for the sun to run out of fuel. So by then, we'll all be dead. Everyone in this room will all be dead, so it will become a big red giant star. And when it cools down, it becomes like a small white dwarf star. And so it will have a peaceful death. It won't be like those other stars that blow up into a supernova and become a black hole. So, you can rest easy.
I wanted to see it though. Oh well, anyways, thanks Melody for the information. I finally have information for my black hole project that's due tomorrow. See ya!
Wait, what? Say that again? Thank you. Are there any questions about anything related to black holes?
Is there any black holes that are known in the Milky Way galaxy?
Yeah, there are actually a lot. I think there's like 16 they found that are like scattered in the Milky Way, and then there's also like the supermassive one at the center of the galaxy. But they're all far away from Earth, so you won't die. Yes.
Isn't the one in the Milky Way galaxy? Is it like we don't really know if it's a black hole? Isn't it a quasar?
What?
A quasar.
What? I'm not an expert on that.
I think it's a black hole.
So I don't really sure what you're asking. I don't. Yeah.
Quasars are believed to be early black holes, when they are still
Is it possible
very
to
much
use
material.
Is it possible to use a black hole as a slingshot to slingshot a ship across the galaxy?
But then dead by the time we slingshot the spaceship.
Not around it, because we can use gravity.
You mean like, are you talking about like a wormhole that like, where you can like, if you go into a black hole, it kind of like
It's kind of like, if we got into it's like gravitational pull. If we
No,
just
no.
use gravity right now,
Are you saying like when something like goes behind a black hole, it kind of warps like time and space?
Well, he's saying like, say this is a black hole, this is ship, like if you could use its gravitational pull to like slingshot around it.
Its orbit.
That doesn't necessarily need to be a black hole. It could be really
Yeah, it could
anything.
be any planet.
It could be a sun.
Like,
Or
it could
star.
be
Well, if
Jupiter.
it's possible, it's probably not possible because the people in the ship would be dead by then. But if you like bring like a satellite, I get it probably wouldn't survive the black hole's like pressure that's like compressing it. It would probably be like yes.
Did you know who came up with the theory of black holes?
No, I don't think so.
I think it was Einstein.
Oh yeah, he had a theory, the rule of relativity. The general
Theory of
rule.
relativity.
Yeah, the theory of relativity, but it's not like proven yet, so it's not like a law. It's still a theory.
Everyone.
No more questions?
I have one. Why do they call black hole? Why these two terms, black and hole?
Oh, well, were you here?
No,
Okay, well,
Before we get into detail, it's black and it's a hole.
yeah, because light can't escape a black hole, so we can't really see it, but we can see the light that bounces off the black hole. It doesn't escape. There's like an event horizon where past that line, light will not be able to, even light can't escape it. So that's why you can't like see a black hole.
But you can actually see where it is.
So how do you see that?
We can tell by the gravity, because the black hole has a tremendous gravitational force, so we can see the effect on other things around the black hole.
Yes, yes. For your information, black hole also radiates some kind of radiations called Hawking's radiation, because it not only I mean, accept everything, like it doesn't allow anything to go away from it, but it in the process of rotation, it radiates, and that radiation is called Hawking's radiation.
It's named after Steve Hawkins.
Yes.
How much stuff could you put in a black hole, like all together, and not be able to jam it?
Isn't it like, I know
Like there's a theory that it eventually leaks out. Like that black holes eventually leak out after it can't.
like to different worlds or dimensions and stuff.
Yeah.
No, but like it just leaks. So it just
Like somewhere random. Just it's kind of like so basically
that's like just and whatever, like, and it's just a little theory.
That's